In today's video, let us see what a CMOS inverter is and how it works. Let us now learn what CMOS inverter is. CMOS inverter, the term CMOS. CMOS stands for complementary metal oxide semiconductor. There's a first letter CMOS together called as CMOS. We pronounce it as CMOS. And in CMOS, look into the term, it is complementary. Complementary in the sense we'll have both PMOS and NMOS transistors together clubbed to build any logic function. And similarly, when you use one PMOS, one NMOS and connect them together, we'll have a simple circuit called as a CMOS inverter. That is what we are going to see now. And here, always in complementary logic, we'll have PMOS transistors on top, NMOS transistors at the bottom. And now, this is a simple CMOS inverter circuit. Now look into the circuit. PMOS transistor is placed on the top, NMOS transistor is placed at the bottom, and both the transistor will have three terminals: gate, source and drain. When we look at PMOS transistor, source is connected to VDD, drain is connected to output, gate to the input. For NMOS transistor, drain is connected to the output, gate to the input and source to the ground. This is how a simple CMOS inverter is being formed. And the other symbol for a CMOS inverter is also shown here. On the left, this is a circuit schematic of a simple CMOS inverter. On the right top, it is called as your CMOS inverter symbol. We'll have a triangle with a bubble. And you can look into the truth table of CMOS inverter where we'll have input and the output as well. When you have your input as 1, output will be equal to 0. When your input is 0, output will be equal to 1. When you look into the inverter operation, how it works. In the previous slide, we have seen that we have two choices. Input is equal to 1 or input should be equal to 0. We had only two choices. Now let us see how the inverter works for both the choices. First consideration, we are assuming your input to be 0. That means you can look into the diagram, V in is equal to 0. When your input is 0, we very well know that PMOS transistor is on, NMOS transistor goes off. This is a simple something like a switch. The transistors are replaced with a switch for our assumption. So now when we say that PMOS transistor is on, there is a path from VDD to output. It has been highlighted, VDD to output. We have a path. Therefore, whatever is in VDD, say this is a 5 volt logic, your output will be equal to 5 volts. When you talk in terms of zeros and ones, when your input is 0, your output should be equal to 1. It is done. Similarly, when we look into NMOS transistor, we say that NMOS transistor is off. Therefore, there is no path for the output or the load capacitor to discharge itself to ground. Therefore, your output will be always equal to 1. Now look into the other diagram where V input is equal to 1. Now, PMOS transistor will be off. On the other hand, NMOS transistor will be on. When NMOS transistor is on, there will be a path for the V out, that is your load capacitor, to discharge to ground. Therefore, the complete charge will be discharged to ground. Therefore, your charge store will be equal to 0. Therefore, your V out will be equal to 0. So, now look into both the diagrams. When the input is 0, your output became 1. When the input is 1, your output became 0. So right now the truth table is verified for both the logics 0 and 1. Now with the same thought, look into the transfer characteristic. This transfer characteristic drawn is an ideal transfer characteristic. It is correct only from theoretical point of view. So what did we say? When your input is 0, your output should be 1. So now look into the transfer characteristics of the inverter. The x-axis we have V in, on the y-axis we have V out. So in V in, when it is equal to 0, at that time V out is equal to VDD, which means logic 1. After some time, when your input is gaining higher voltages, when it reaches VDD, obviously your output should go low. That is logic 0. So both have been verified with your characteristic curve. So this figure shown in the slide is your ideal transfer characteristic curve. In this slide, let us look into the advantages and disadvantages of a CMOS inverter. The advantages are it takes very little power, it has got high noise margin, good temperature stability, and the structure is very simple. The disadvantages are it is very difficult to fabricate because you have to fabricate both PMOS and NMOS transistor together in a same silica. And also the other disadvantages is it requires more space in an IC because here you need both PMOS and NMOS, two transistors in order to fabricate one simple inverter. But in case of NMOS inverter, it is enough to use only one transistor. Right now, at this stage, we will not be able to justify each and every advantage and disadvantage. As we later progress through different videos exploring CMOS inverter, we will be understanding the advantages and disadvantages in detail. In summary, we have seen what CMOS stands for and how a CMOS inverter circuit schematic looks like, its symbol, truth table, and how a CMOS inverter works for various inputs like 0 and 1, and also its advantages and disadvantages. In the forthcoming videos, let us learn more about CMOS inverters. Thank you.